Hello, welcome. I'm going to post how to solve or what the answers are for this worksheet and go through it. So right off the bat, go over some of the definitions. Voltage is energy per charge. What we spoke about with our analogy, that's the dollars per car that goes through a toll booth. But in real life, it's how much energy electrons give off when they go through, or each electron gives off, or a group of electrons, a coulomb. Flow of current is the flow of electrons, and our analogy is the flow of cars. Okay. Power is energy per time. We didn't really use that in our analogy. And then opposition is resistance. Okay, and then that's going to be like toll booths. So for our analogy, we said that when cars go through toll booths, they give money. And the amount of cars that go through a toll booth is kind of like the traffic or the flow of cars. The way that relates to circuits is when circuits go through a resistor, they, instead of giving off money, they give off energy. And instead of counting cars, we're counting actually electrons. And whenever we talk about 1 amp is 1 coulomb per second. And that is just, coulomb is just a certain number of electrons. And that's one of the things that we learned. All right, in the static electricity chapter, we learned about coulombs. All right, so some of the things that we have here is we have power. The symbol for that is capital P, and watts is the unit for that. Many of you probably remember my lame joke of watt is unit of power is a statement, not a question. Okay. For energy, we have E, and that's joules, and that's a capital J. And then for current, it's I, which is something that is tough for a lot of kids, but that's measured in amps, or amperes is the official name, but often is abbreviated by amps. Then we have V for voltage, and the unit is volts for that. And then we have resistance, and that's measured in ohms. Now, if we used, like let's say we said we had 5 ohms, and then we said 5, and then we used O, well, that would look like, would be confused with 50. And so they used the Greek letter omega instead of that. Okay? So those are all of the terms and their units. One of the things we're going to be working on next is the junction rule. And basically, the current going into a point in a circuit equals the current leaving the point. Basically, that's a fancy way of saying that current is conserved. So we have 4 amps coming out here. We have 1 amp that goes here. That means that this must be 3 amps. Because 4 amps goes into that point, 1 amp goes this way, then that means that 3 must go that way. We don't ever lose any amps or current. Okay, so that's 3 amps. For here, we wanna find out what I2 is. Well, we know we have 3 amps here, 1 amp there, but we don't know how much is going into that point. We know 3 leaves that point to go this way, 1 goes that way, but we don't know how much goes that way. However, if we look here, we have 5 amps going into the power or into the voltage source or battery, which means that 5 amps have to leave it. We never lose current. Current gives up energy, but we never lose current. So that means that we have 5 amps going into this point, 3 goes here, 1 goes there. That means another 1 amps must go here, and then it all comes back together right there. We have 5 amps again, and that means we have 5 amps right at that point. 3 goes this way, that means that 2 amps goes here. And that is the junction rule. Junction rule is something that you are going to need to understand for the test. Okay. Then we have the loop rule. The loop rule says that any way we go around a circuit, we have to lose all the voltage. In this example, we have 50 volts. That means when we go around any path, whether we go this, this, and that, it's going to be 50. This, and that is going to be 50. Or this, and this. There are three possible paths. We have to drop 50 volts. This one, we know two out of three. We know this is 12, we know this is 8. So this must be 30, because 30 plus 8 plus 12 is 50. Okay? And if we went this way, this would also be 8, or this one's also 8. This is also 8 volts. Because if we go this path, like that, it has to drop 50 volts. Okay? So this one is 30 volts, and this is 8 volts. Things that are in parallel with each other have the same voltage. Okay? That's another thing that we learned. All right, for total resistance, when we're looking at a series circuit, total resistance is this formula, is R1 plus R2 plus ... Okay, so this is really simple. It's just 6 plus 12 is 18 ohms. This one's a little bit harder. Our formula is this: 1 over RT is equal to 1 over R1 plus 1 over R2 plus ... And what that ... means is that repeats. So if we had 3 resistors, then it'd be plus R1 over R3, or plus 1 over R4 if we had 4. But we only have 2, so we just go 1 over RT is equal to 1 over 6 plus 1 over 12. And a lot of kids do this right until the very end, and I'll show you what I mean. So we go 1 over RT is equal to 2 over 12 plus 1 over 12, okay? And then we have 1 over RT is going to be equal to 3 over 12. And this is where a lot of kids get lost, is they just put their answer as 3 over 12 or a fourth. However, we have to flip everything. So we're going to flip this. That's 1 over RT over 1 is going to be equal to 12 over 3. And then to solve for RT is going to be 4. Now you'll notice that 4 ohms is less than either 6 or 12. And that is one of the things that we learned. When things are in parallel, the total resistance is less than either resistor. 4 is less than that. When they're in series, it's more than either of them. It's actually the sum of the two. This makes sense with our analogy. When we have one toll booth after another, that slows us down more, or slows things down more, and so we have less current. When we have toll booths that are side by side, that actually decreases the resistance and makes it so more cars can get through. Or like when you're at Jewel or Trader Joe's or wherever you're at getting food, the more lanes that are open side by side, the less resistance there is, the easier it is to get out. Okay. For this one's a little bit challenging in that we have a combination. These two are in parallel with each other, but together they're in series with this and this. So the total resistance of these two, we go like this: 1 over RT is equal to 1 over 12 plus 1 over 24. We have 1 over RT is going to be equal to 2 over 24 plus 1 over 24. And that's going to be 3 over 24. When we flip everything, RT is going to be equal to 24 over 3, which is going to be 8 ohms. So all of this acts like an 8 ohm resistor. And so basically what we have is we have a circuit that's like this, where we have a 2, an 8, and a 5. But our 8 ohms is made by having a 12 and a 24 in parallel with each other. And so the total resistance of this whole thing is going to be 15 ohms. Okay. This actually took this off before I posted it, so we're not going to do that one. We're just going to do this here. With a series and parallel circuits, this is a series circuit here, and this is a parallel circuit there. We can easily break this down. The easiest thing to do, try and study this a bit. The easiest thing to do is to take the 6 plus the 8, because when they're in series, we learned that we just add them. We have 14 ohms. Our total voltage is 42 volts, so we take 42 divided by 3, because we know that for all circuits, V is equal to I times R. So if we, in this case, we're going to have 42 volts is equal to I times 14 ohms, and I will be 3 amps. Now, since there's only one path for the current to take, right? There's 3 amps through this, 3 amps through that, 3 amps everywhere in a series circuit. And so we can just do V is equal to I times R. So if 3 times 8 is going to be 24, and 3 times 6 is 18. Okay, and then we're done. Now this one, it would be easy if we just added them, but that would not be correct. As we talked about on the last page of the review, the total resistance is going to be less than either 30 or 60. It's not going to be 90. If they're in series, that'd be 90, but it's not. So what we have to do is we have to go like this. We have 120 volts across everything, because things that are in parallel all have the same voltage. This has 120 volts, that does, all 3 things. Okay, so we take 120 divided by 30, we get 4 amps. 120 divided by 6, we get 2 amps. Now, based on the junction rule, we're going to have 6 amps coming out of here, just like we spoke about before, which means our total resistance is going to be 20 ohms. I can solve for it that way, or I could have also done the 1 over RT is equal to 1 over 60 plus 1 over 30, and that would also give me an RT value of 20 ohms. Okay, so resistors in series have the same current. We saw that here. All three values are 3 amps. In parallel, they have the same voltage. All of them are going to be at the same voltage. Okay. As resistors are added in series, current decreases and total resistance increases. So if we were to add another resistor to this, the total resistance would be more than 14, and the current would be less than 3. This would go up, that would go down. Anything you add, if you added a 6 ohm resistor, this would go from 14 to 20, and then the current would go down to be far less than, or a fair amount less than 3 amps. It'd be more like around 2 amps. In this case, if I were to add, say, a 20 ohm resistor to this circuit over here, just added another resistor, that would also be at 120 volts. And so then, like, let's say this was 20 ohms. Now we'd have another 6 amps going through here, which means we'd have twice the current and half the resistance. So it'd be, the total resistance would be 10 ohms, which would be even less than it is now. Okay, so as resistors are added in parallel, current increases and total resistance decreases. This is congruent with what we learned about our analogy, whether it's toll booths or checkout lines. As you add more side by side, like this, the total resistance goes down and the total current goes up. Just like when you're at the store, the resistance of getting out of the store goes down when more lanes are opened, and that means more people get out, or more people per minute get out. If you have any questions, please email me them, and I do hope that all of you are staying healthy and your families are doing well. Take care. Bye.